Basic concepts in statistics. The objective of the video is to introduce to you on the basic concepts in statistics. Let's start it with the two branches of statistics. The first branch is what we call the descriptive statistics. From the word describe, what we do here is we try to represent data, describe data using the population. Oftentimes, this is shown as it shows the prevalence of variability. When we talk about variability in statistics, this is what is different from the norm. In descriptive statistics, we have tools, tables, graphs, averages, ranges, and correlations to use. In other words, we try to organize and summarize data. Example under descriptive statistics are the following. Ranking of the most favored presidential candidates. How is this considered descriptive? It's because presidential candidates would likely focus on the entire voting population. So it does not only include a certain part of the country, but more likely, ideally, to use all the people voting population of the entire country. The next example is the graph showing the annual change in temperature. This one, in terms of time frame, for statistics to be descriptive, it has to be done for a longer period of time. In this case, it is done annually. The next branch is what we call as inferential statistics. And this type of statistics uses tests, estimates probability. And what we focus here is the sample of the population. Example, we have pollsters claim that majority of people favored candidate A. Only a part of the candidate was being focused, not the entire candidate. So this is just simply inferential. Where can you see this? You might be hearing this during SWS surveys, right? More likely surveys. Number two example, researchers claim that the average age of teenage pregnancy is between 12 to 16 years old. This is just an estimate, a representation that assumes that the teenage pregnancy is between 12 to 16. So not really based on the entire population of teenagers and those under teenage pregnancy. To summarize, descriptive statistics describe data. So what does it do? It collects, it summarizes, and of course describe. The method used here is deductive method, meaning we focus on the general aspect of the data. Inferential statistics, on the other hand, uses the sample of the data. We could be speaking about voting population, and if it's descriptive, you will focus on the entire country, meaning if there are 30 million registered voters, you will have to focus on the 30 million registered voters for it to be descriptive. Inferential, on the other hand, in terms of voting, is when we only focus to a certain part of the actions of the voting population. For instance, if we only focus on the voters living in NCR or living in Region 11, that's just simply inferential statistics. So what do we do here? We draw conclusion, we make decisions based from what we've observed from the sample of the population. That's why when we observe during elections, national elections, there are estimates, there are predictions as to who are the leading bets in the candidate presidential race, senatorial race, or the like. Inferential statistics is being used there. So the method is inductive method. So in this case, we are focusing on the more specific version of the entire population. So how do we further differentiate the two? Again, descriptive statistics focus on the general aspects of the data, while inferential statistics focus on the specific aspects of the data. In terms of wording, you can find keywords in descriptive statistics if it uses past tense, while inferential statistics will use future tense or present tense more likely. Because under inferential statistics, since it's being used as an estimate, it's often ongoing. It's not yet concluded. To further our understanding about the branches of statistics and how it's being interpreted, I would now present to you the definition of what population and sample is in statistics. So when we talk about population, this is focusing on the entire subject of a certain research or study. For instance, we'd like to see um, we'd like to know how many students are enrolled in DNSC, total enrollment in Davao del Norte State College. So if we talk about population, then we have to include everybody. That means first year, second year, third year, fourth year, and if there are fifth years, they should be included. All programs are included in all institutes. No one is exempted. That is population, meaning we focus on all the students involved, no designations. However, if we talk about sample, and since sample is just selected from a population, if we're talking about DNSC, the entire enrollment of DNSC students, uh, that would be your population. In sample, if we only pick a certain program, for instance, uh, your program, for instance, would be would be an example of, already of a sample. So in representation, the entire shape here is our population. And in research, we call it the parameter. While a part of that circle, just the slice of that, is our sample, and that's what we call statistics. Another term that is important to understand when we talk about population and samples is the population of interest. For instance, a mayor running for office has 4.4 million registered constituents in his town. He commissioned for a survey where 38% of the 5,000 registered voters interviewed said they will vote for him. So what is the population of interest? What is the focus? Who were um, chosen to be part of the study? The answer is the 5,000 registered voters interviewed. 38 is just a part of 5,000, and 4 million is your population. But who are you focusing in the study is the 5,000 instead. Hence, they become the population of interest. Sample of the study. There are 2,000 species of grass in the Mabuhay Eco Park, and 950 grasses were randomly picked and analyzed according to this data, which is the sample of the study. So the sample of the study here is the 950 grasses randomly picked. The other important terms that we need to be familiar of when we talk about statistics is the variables and the types of data we use in our study. Why do we need to differentiate these terms? It's because by understanding these concepts, we can effectively choose the analysis, statistical analysis that we will be employing in our research or study. First, we have the general term variables. The meaning of that is the characteristics or attributes that will be represented into different values. And this variable is what you're going to focus in your study. You would like to see changes there, overall movement and the like. A specialized type of variable is what we call a random variable, and this is usually in the probability of or by chances. More likely, lotto results are under random variable. Data, on the other hand, is the numerical representations, not always numerical, but the values you incorporate to your variable. So a variable may be represented into data once it is measured or observed. So these could be represented using words or numbers. Another term here is quantitative versus qualitative variables. So first of qualitative variables. Quality, meaning these are acquired through observations. Example here is that when we categorize things, the categories we're often used to is gender, religion, nationality, affiliation, color, anything that is done through observation. Next is quantitative variables. Still through observation, but sometimes we use specialized tool or we represent them into numbers to actually show these variables. So these can be ordered, ranked, or the like. But the example here is height, weight, age. These are measured. These are counted. These require numerical representations. Under quantitative variable, we have the now, quantitative and qualitative variable can still be further differentiated into independent and dependent. We start with our independent variable. So when we say independent, it can stand alone. But if we refer this one to the cause and effect relationship, but not every time na cause and effect relationship, but more likely independent variable is the cause of the change. That's why it has a causative role in when we talk about cause and effect relationship. This is also what we mean as our treatment variable. Selected and manipulated because that's how we would like to see changes through um, certain through selection and certain manipulations. And overall, this is what we call as our explanatory variable. The group, if you have a research and you will focus on certain groups, independent variable or variables are administered to treatment groups. There are different types of independent variable. We have the quantitative independent variable, and for a quantitative independent variable, suppose you would like to study an effect of a certain drug. In here, for quantitative independent variables, you only focus, you use a treatment, the same treatment with varying amount. For instance, the drug could be administered to different groups of people who will also receive different amounts of drug. And you will be comparing the results of the effectivity of the said drug. That would be quantitative independent because you're just using the same treatments in just different levels. Its opposite is the qualitative independent variable where it uses different treatments or different kinds of treatments. So the example earlier was just a variation of the amount. In this case, you will really have to give a different treatment. For instance, you would like to know which of these cooking ingredients would make your baking better. So you can have no baking powder, no egg, no oil, regular. These are different treatments. So you may compare these things because of the variations of changes. not dependent on the amount. So those are what we call the independent variables. Next one is our dependent variable. And if you're still referring to the cause and effect relationship, dependent variable is the effect part of the relationship. So it's the resultant variable or the outcome variable. And that's why it's dependent, because its effect is usually dependent on the amount or the treatment that you receive. So depending on the independent variable, the dependent variable's result varies depending on the inclusion of the independent variable. Another important variable that is part of the study is what you call the controlled variable. So when you say controlled variable, um, this does not receive any special treatment. It's the normal aspect of the study for comparison. For instance, you would like to know if a certain program is really effective. So you will have a certain group, which you call the treatment group, who will receive the said program. While you have another group that will just do whatever they want the usual way. And since they're allowed to do anything the usual way, then that's what we mean by controlled variable. So oftentimes we use a controlled variable to actually show the changes in the controlled, the effect of the treatment that is being done. So in experimental studies, we often really observe independent variables in action. So when we perform experiments, there are disadvantages. First is the Hawthorne effect. Hawthorne effect is when participants or subjects in the study know that they are being studied. For instance, when you were in elementary, perhaps you were subjected to observations, and your teacher would tell you to behave better, to answer well in class because you are being observed. That alone is affecting already the result of the study, because there is already an incorporation of a different type of manipulation. You will act differently because you know you're being observed. That's Hawthorne effect. The other one is the confounding variable, and it's very important that this is the reason why you would like to limit the generalization of your study, because of the confounding variable in any researches or study. Confounding variable is the variable that is not actually part of your focus in the study. However, you will include it. However, it will affect the study greatly. For instance, you would like to focus on the effect of a certain drug, a certain diet to reduce weight. That's what your focus is. Diet as your independent variable, and your dependent variable is the reducing of weight. Diet should only be the reason why you will reduce weight. However, you might not expect that their personal sleeping habit, if they have existing diseases that affect them to regulate their weight, could become your confounding variable. Are they smoking? Are they sleeping well? Do they exercise? And since your independent variable will only focus on the diet, the other three that I mentioned could greatly affect your uh, the, the reducing of weight factor. But then that's not part of your study, so you have to be careful about this when you will perform research, because this will make your research not conclusive. So overall, this is what happens. For instance, you would like to focus on the growth of a plant. Water here is your independent variable. The growth of the plant is your dependent variable, and your the amount of soil that you use or the fertilizers that you receive should be constant or the same all throughout, and that would be controlled variable. Since what's being shown here is that water is your only independent variable, sunlight can become your confounding variable if it's not part of the focus. The humidity of the surroundings, where you have placed it. Was it a dark room? Is it just in the green room and so on? Those could become confounding variables that might greatly affect the study. Nevertheless, at least we have differentiated them. The next focus is in discrete and continuous data. This is when we um, try to distinguish what type of quantitative variables or what type of data should we obtain under quantitative variables. So first off, we have discrete variables. So when we talk about discrete variables, they assume values that can be counted. So regardless of the form, suppose we would like to focus on rock, large rocks, medium rocks, very small rocks. These are just counted as one, regardless of size. So in most cases, you're going to tally. That's discrete. Um, in terms of representation, we will have frequency distribution, categorical frequency distribution. Continuous variables, on the other hand, if the other one was counted, this one is when we would like to use measuring tools to obtain values. So in this case, we assume that the number can be infinite. In other words, we cannot just simply label it as just 1, 2, 3, and 4. Sometimes there are fractions, sometimes there are decimals. So there is no exact value here. Examples are, of course, what are the things that we often measure? We have time, we have length, we have weight, we have height, we have many other things that is performed by, many other data that requires that they should be measured. Continuous variables are, we can still use frequency distribution, but this time we will have group frequency distributions. In other words, we will use boundaries here. We'll also use class boundaries and other aspects in the making of the table. To summarize, we have the following. So data can be differentiated into quantitative, ranked, qualitative. Qualitative, most often, they are adjectives, words. Discrete, quantitative can be divided into two. There is discrete, and we also have continuous. For discrete, it is countable. For continuous, it is measurable. So we can welcome decimal values here. Levels of measurement. This is also a very important aspect in the study or in research because we have to know what type of levels are there for us to really effectively distinguish what specific statistical tool should we employ. But beforehand, we need to know first our data. The classification of data sources. We have primary, that means the researcher is the one who initiates the gathering of the information. We may probably do it via interview, survey, observation. Secondary data, on the other hand, is when you use repositories or other people's data for your research. You may go to PSA, Philippine Statistics Agency, for informations on population. You may also go to the SWD and the likes. Any governing bodies who are tasked in um, gathering informations of the population. You can do that. So secondary data. How do we classify these things? The data you obtain from primary sources or secondary sources are differentiated into different levels. You have nominal, ordinal, interval, and ratio. We begin with nominal scales. Do not be surprised if you hear levels, numbers, or scales. Those words are used interchangeably when we talk about levels of measurements, how we scale these measurements. So first off, we have nominal. So nominal meaning we just label things. Use it for identification. So the number here are just simply a representation of something. Example, ID number, plate number. So in cases of ID numbers, you cannot use the number here to anything. For instance, you answer a yes, no question where you label yes as 1 and no as 0. One here, one here is just to represent yes, and 0 is to represent no. In terms of plate number, you cannot differentiate the type of car, how brand new the car is, or how old the car is, in terms of their plate number, because the plate number is just the identification for that. The next type of measurement is the ordinal level, where we classify or categorize data via ranking. Um, what do we mean by the statement ranks? Differences between ranks do not exist. Now, when we talk about ordinal numbers or ordinal data, we don't see these numbers as numbers in the number line. Because if we think of it as the numbers in the number line, there could be the numbers in the number line may have decimal values. This could be represented into rational values, which is not applicable in ordinal. So the purpose here is only to rank. There is no rank 2.5 here. There is no rank 3.2. All the ranks here is rank 1, rank 2, 3, 4, and 5, no other. So example here, SAT score, grade, and the purpose of the SAT score here and grades is for comparison, for ranking, for ordering, for judgment, if you would like to. Because under ordinal level, that's what the purpose of these numbers are for, to show the in reality, the natural order or ranking of things. The other scale measurement is what we call interval. To do this, to have these values, we often measure these values. And through measurement, we will obtain values and represent these values into numbers. However, 0 here is not meaningful. There is no true 0 value. How do we differentiate this one? I'll explain further later. So example here is temperature, IQ score. The last one is ratio. There is the very minute difference in terms of how we differentiate ratio and internal scale. We have true 0 value for ratio. When we talk about true 0 value, when you measure, and if there's no measurement, then 0 is true. Example, height, weight. Now, how do we differentiate these two, interval and ratio numbers, in terms of the usage of 0? 0 in real description is that there is absence of something. So if it's 0, then there is none. However, for internal values, 0 means it's still there. Example, temperature. When we say it's 0 temperature, it's not that there's no temperature. There is temperature, but it's 0. In other words, there's a possibility of a negative value. IQ under interval is still considered because there is no such thing as zero IQ. There is no negative IQ. But then, um, there could be lower than that, but theoretically, none is presented yet. But IQ cannot be um, nothing. Everybody should have IQ. So in interval, in terms of numbers, there is a possibility of having a negative value. So zero is still something, it's still there. However, in ratio, when we say zero height, there's no more height and there's no possibility of any negative values. Weight is also another example. So to summarize all of these, starting from the data, we start with qualitative. Qualitative is obtained through the usage of words. Our observations are often presented in this manner. So we try to classify them. So sometimes they are nominal. Not sometimes, oftentimes. Data, when we talk about numbers, we can have relative standing or amount slash count. In terms of relative standing, we have ranks. And when ranking, we're trying to order things. And since it's ordering, that is ordinal. For amount or count, that's example of quantitative. So either it's equal intervals, meaning it could have negative values, or through zero. The example for this, the scales for this one is interval or ratio. So these are my resources. Thank you.